So taking a look at equilateral triangles, remember that equilateral triangles are triangles with 3 congruent sides where all the sides are the same. So relating that back to this idea of the relationship between the size of the side and the size of the opposite angle, if all 3 sides are the same, well, then that means that all 3 angles must also be the same. Okay? Because if the opposite sides are the same, the opposite angles are the same. So if all the sides are the same, then all of the opposite angles, so all of the angles are the same. For example, when I look at something like this guy, once again, if all 3 sides are the same, so this side has angle x across from it, this side's the same and it has this angle across from it, this side's the same and has this angle across from it, all 3 of those angles are across from a side that is the same, so all 3 of those angles must be the same. And so if all 3 angles have to be the same, well, let's think about it this way. They have to add up to 180, right? And so these angles have to add up to 180 degrees. But that 180 degrees has to be split evenly among those 3 angles. So I just divide that by 3. And when I do that, it gives me 60 degrees. And so this has to be 60 degrees. Well, they all have to be 60 degrees. Okay? And so when you think about an equilateral triangle, well, the angles inside an equilateral triangle are always going to be 60 degrees for all 3 of them because they're always going to be the same, and we're always going to have that measurement of 60 degrees to make them the same, okay? And so for this one, x equals 60 degrees, okay? Using that same thing but in reverse, here I have the 3 angles being the same, and so if the angle is the same, then the side opposite those angles also has to be the same. Okay? So if one of those angles has a 5 inches across from it, well, then all of those angles have to have a 5 inches across from it. Okay? Which means for this one, x is going to equal the 5 inches. And again, it's just all about that relationship of the size of the angle and the opposite side. If the angles are all the same, then all those opposite sides have to be the same. If I look at this guy, this one's a little bit tricky because it looks like it's labeled as an isosceles triangle, but look at which things are labeled as the same. Notice it says that this angle and this angle, these 2 angles are the same, which means their opposite sides have to be the same. So watch this. This side has to be the same as this side according to this. And so when you think about that, because the angles are the same, their opposite sides have to be the same, that means that this side over here has to be 7 feet. And so as I think about that for a second, let's go back to the way things are labeled here. Look at the little dashes on the sides right here. This side has to be the same as this side, which means this side over here is also 7 feet. And so as I start to look at this, I already have y, but now I also have that all 3 sides are actually the same, which means that all 3 angles must be the same. This is an equilateral triangle, which means x is automatically going to be a 60 degrees. Okay? And you could go through and say, hey, all the angles are the same. They have to add up to 180, so 180 divided by 3. But that's going to work out the same way every time. When it's an equilateral triangle, each angle is 60 degrees. And y was the 7 feet. Okay, so we have to kind of look at what's labeled and kind of bounce around and say, hey, you know what? This side has to be the same as this side based on the angles. And these 2 sides are already marked as being the same, so find all those missing pieces. Okay?